Okay, today you might want to take out a piece of loose leaf paper so that you can take notes while we're going over this. We're going to talk about factoring trinomials with a coefficient greater than 1. Your teachers in the past might have called it the AC method or the headphone method. Okay, the AC term comes from this is your A, this number is your B value, and this number is your C value. So it's called the AC method because we're going to multiply the A times the C. Some teachers call it the headphone method because when you see a number in front of the x squared, you circle it and you make headphones to the last term. So the first thing that you must know is that standard form of any trinomial is ax squared plus bx plus c. The a, b, and c values are numbers, not the letters. Don't ever take the x squared or the x when you're taking your ABC values. So to factor a trinomial with a leading coefficient, first thing you're going to do is multiply the a value by the c value, or draw the headphones. Then, we'll write headphones here. Find the factors of AC that add to B. We're going to expand the middle term of the trinomials using those factors, and then we're going to follow yesterday's steps by splitting the expression in half by drawing a line down the middle, factoring out a greatest common factor on each side, and then what's left in the parentheses should be the same for both halves. So the first factor is the two GCFs, and the second is the repeated term. So if we look at example number 1, there's a number in front of my x squared. So either draw your headphones or write AC. Off to the side, 2 times 3 is 6. Now we're looking for factors that multiply to 6, but that add to 7. So I'm going to list my factors, 1 and 6, 2 and 3. The next set would be 3, but it's already on my list here, so these are the only factors. The ones that add to 7 are 1 and 6. So now I'm going to rewrite my problem, 2x squared. I'm going to use these factors, plus 1x plus 6x, because that replaces the 7. 1 plus 6 is 7, and then plus 3. Now we follow the steps from yesterday. Cut it down the middle. On the left, your greatest common factor is an x. If I take an x out of each of the first 2 terms, I'm left with 2x plus 1. I have to be left with 2x plus 1 on this side. So if I do 6x divided by 2x, here, the first terms, that's 3. So my factors are the fronts, x plus 3, and the repeated term, 2x plus 1. If I wanted to check that I factored it correctly, I could draw my 2 by 2 box and put an x plus 3 here, a 2x plus 1 here. If I fill in the box and multiply everything, I will end up with the question. Next one. First thing, I notice that there is a number in front of my x squared. So I'm going to either draw my headphones or multiply a times c. So I get -6. Now I have to find the factors of -6 that add to positive 5. So my factors of 6, again, are 1 and 6, 2 and 3. Since it's negative here, one of these has to be negative. Which ones add to 5? These. So I'm going to rewrite my problem. 3x squared. I'm going to use these terms here, minus 1x plus 6x minus 2. Just a side note, it does not matter if you flip-flop these. If you put the 6x first and then the negative 1x, you're still going to end up with the same answer. Your GCFs would end up being the opposite of what the greatest common factors are. So here, on the left, my greatest common factor between a 3x squared and a 1x is x. I'm left with 3x minus 1. On the right, I want to be left with 3x minus 1. So if I cheat, 6x divided by 3x is 2. So my factors here are the fronts, x plus 2, and the repeater, 3x minus 1. Next one. Again, I see there's a number in front of my x squared term, so I'm going to either draw my headphones or write AC. 2 times 10 is 20. I'm going to list all the factors of 20. 1, 20, 2, 10, 3 does not go into 20, 4, 5. The next one here would be 5. It's already on my list, so I'm good. Since I want to add to negative 21, that means both of these have to be negative. Because two negatives, when I multiply, gives me a positive, but when I add them, I get a negative. So looking at the list, which two add to negative 21? Those. I'm going to expand the middle term using those values. So I'm going to rewrite this as 2x squared minus 1x minus 20x plus 10. I'm going to then cut it down the middle. On the left, my GCF, my greatest common factor, is x. If I take an x out of each term, I'm left with 2x minus 1. I need 2x minus 1 here. So on this side, negative 20, x divided by 2x is negative 10. My factors are the fronts, x minus 10, and the repeater, 2x minus 1. Last one. Again, I see a number in front of my squared term, so I'm going to do 4 times negative 5. I get negative 20. I'm going to list the factors of 20. 1 and 20, 2, 10. 3 does not go into 20. 4 and 5. My next term would be 5. It's already on the list. Since this is negative here, I need 1 of each. I want them to add to negative 1. We want to add to negative 1. 20 minus 1 is 19. 10 minus 2 is 8. 5 minus 4 is positive 1. I want negative 1, so I'm going to switch those signs, because if I multiply them, I still get my negative 20. But now, if I add these two, I get my negative 1. So I'm going to rewrite the problem. 4y squared. Use these terms to expand the middle, plus 4y minus 5y minus 5. Again, I'm going to cut this down the middle. On the left, my greatest common factor is 4y. So if I pull that out, I'm left with y plus 1. On the right, I need to be left with y minus 1 also. So we can cheat. Negative 5y divided by y is negative 5. My factors become the front terms, 4y minus 5, and the repeater, y plus 1. Again, any questions? Please email me, write them down, ask me when you see me.